Hello and welcome to lesson number 6 in Unit 0 of our Grade 10 Academic Math class. This is Expanding Polynomials and the Distributive Property, Part 2. So it's a continuation of what we were working on in lesson number 5. We're just going to look at examples that maybe require a little bit more, there's a higher level of complexity. So without further ado, let's jump right in here in our first example. As usual, I'll recommend hitting pause here, copying this example down so that you can listen more fully while I'm explaining it. So hit pause, do that now, and come on back and I'll talk you through it. Okay, you're back. This is two sets of binomials being expanded out. The difference this time is that they are then being subtracted one from the other. Now the trap that students fall into here is that they don't complete the second set of expansions before subtracting every single piece of the second binomial's expansion. So let's start. First part's again pretty straightforward. It's very much what we've been doing. We have some expansion here, 2x times 3x, 2x times 2, negative 5 times 3x, and negative 5 times plus 2. And you get this bad boy right here. 6x squared plus 4x minus 15x minus 10. And then you'll notice in the next line down, what I've done is I've simplified it by gathering together the like terms, 4x and minus 15x. That gives you 6x squared minus 11x minus 10. That part's pretty straightforward. It is the second part that people find difficult. So we're going to expand out the second set of binomials. And what you'll notice is that I put in these sort of artificially inserted square brackets. The reason I do that is because, as I said, our tendency is to start this expansion and not include it in a bunch of brackets. So you can imagine that, and just for the sake of argument, I'll erase those square brackets for a moment here. What you end up getting is minus 20x squared. But what you're supposed to do, if you look to the line below it, you're supposed to subtract 20x squared, and then the simplified middle term, minus 11x, and then minus 3. That doesn't happen in this scenario. If you don't include those actual square brackets, the tendency for students is to forget that you have to distribute that negative to all of the terms in the second expansion. So I'm going to put those square brackets back in because I think they're important. Having expanded it out, again, that's 4x times 5x, 4x times plus 1, negative 3 times 5x, and negative 3 times plus 1. You get this, whoops, that's not a highlighter. You get this bad boy right here. We gather together the like terms, the plus 4x and the minus 15x, to give us our minus 11x. So now, we'll zoom out a little bit. We have our first binomial expanded out and simplified. Our second binomial expanded out and simplified. Now we have to get to the mathy part of it, I guess you would say, where we are going to be subtracting all three of those terms. And the important thing to note is when you minus and this is a positive 20x, and we wouldn't, 20x squared rather, we wouldn't write that. But when you subtract a positive, you end up getting a negative. If you're going to simplify those two signs banging up against each other with no numbers in between with a single sign, you get a minus. Moving to the second term, minus negative 11x, that becomes plus 11x, and minus negative 3 becomes plus 3. And as I said, that's the part where students tend to make mistakes. From here, it's just about gathering together the terms that are alike. So if we look sort of through this, we have a 6x squared, we have a minus 20x squared, that's going to give us minus 14x squared. We have minus 11x plus 11x, that comes up to 0 x's. And last but not least, we have minus 10 and plus 3, which gives us minus 7. So, takeaway from this question is when you're expanding out a binomial that you are eventually going to subtract, include those square brackets as a way of reminding yourself, I have to subtract every single term in this expansion, not just the first part. We're expanding the result of a distribution, which is a polynomial. We have to subtract every piece of that polynomial, not just the first one. Okay, let's look at the second example, which I've got started here. Similar to the first one, except that instead of there being a second binomial that's already written out long style, it's written as a binomial squared. Again, I always recommend that instead of trying to do it in your head, you do a rewrite step, which is what I've done here. So I've expanded out in this first line, I've expanded out the first binomial. 3x times 5x gives us 15x squared, etc. And then you get to the subtract the second binomial. Now I've just rewritten it here, so the next step, or the step in the next line, is going to be to expand out that second binomial that I've just rewritten. At the same time, I'm going to simplify here the terms that are alike. So I've got 15x squared. I have plus 3xy minus 10xy. That will be negative 7xy minus 2y squared minus open my square bracket, and now I'm going to do that expansion. So 2x times 2x gives me 4x squared. 2x times minus 5y is minus 10xy. Minus 5y times 2x is minus another 10xy. And lastly, minus 5y times minus 5y is plus 25y squared, close bracket. Next line is going to be a rewrite for the most part. 15x squared minus 7xy minus 2y squared minus, and now I'm going to simplify the contents of these brackets. There's my 4x squared. The two terms that are alike are sitting right here in the middle, so that's going to be minus 10xy minus 10xy is minus 20xy, and there's our plus 25y squared. And again, hopefully now you can see that now that you've seen me do it in real time, that you can recognize the value in subtracting 4x squared, subtracting minus 20xy, subtracting plus 25y squared. So let's, again, mostly a rewrite here. This time now we're going to be distributing the negative to all three terms in our second expanded binomial. 15x squared minus 7xy minus 2y squared. So minus a positive 4x squared gives us minus 4x squared, minus negative 20xy is plus 20xy, and minus positive 25 is minus 25y squared. And now we gather together the terms that are alike. We have 15x squared minus 4x squared, so that's going to give us 11x squared. We have, just changing up the colors, minus 7xy and plus 20xy, that's going to give us plus 13xy. And last but not least, we have minus 2y squared and minus 25y squared. That will give us minus 27y squared. Expanded and simplified. So we're doing all right here. Things are happening. It's looking good. Based on the time of the video here, let's see if we can squeeze out one more. So last new bit of learning here. We have this time a binomial, two terms being multiplied by a trinomial. More complicated? Yes, but absolutely the same principle in that we are going to multiply 2x by all three of the terms in the second or polynomial, a trinomial. So let's do that first. We have 2x times 3x squared. That will give us 6x cubed. And 2x times 2x is plus 4x squared. 2x times plus 5 is plus 10x. So we have expanded out the first binomial, or the binomial into the first term in the binomial into the trinomial. Now we're going to do that same thing with the second. We're going to do minus 1 times 3x squared, minus 1 times 2x, minus 1 times plus 5. And let's get that lined up. So first, minus 1 times times 3x squared is minus 3x squared. Minus 1 times plus 2 is minus 2x, and minus 1 times plus 5 is minus 5. At this point now, it's just a collection of terms. We are going to gather together the ones that are alike. So we have a 3x cubed. It's the only one that's 6x cubed. It's the only one that's like that, so let's pop that in. Next, looking down the line, we have plus 4x squared, and there's another x squared term, minus 3x squared. Plus 4 minus 3 gives us plus 1, or just plus x squared. Moving down the line, we have plus 10x minus 2x. That's going to give us plus 8x. And last but not least, there's that minus 5 all by itself. So there we go. We expanded out a binomial by a trinomial. Same principle, just a little bit of a different, the more terms just to keep track of, I guess. We're going to do one more example here of 3 sets of binomials being expanded out. We're going to do that in the next video, get to sort of a word problem at the bottom, and we're going to call it a day on this lesson and on this unit. So we'll see you in part 2 of this video.